At Attomarker, we have been developing a new technology that will enable us to analyse from a standard prick of blood all the tests that your GP would perform for you if you went for a consultation. So this is a real-time demonstration video of our technology. My finger's just been pricked with a standard lance, and a 5 microliter sample has been extracted from the resulting drop, and is now simply going into a dissolution buffer where it's been diluted about 100-fold to prevent any coagulation in the microfluidics. It's now being drawn into the instrument automatically. Zooming in on the interface of the instrument, you can see somewhat of how the technology works. There's an array of tests on the right hand side, and in principle each of the spots on the right hand side could be functionalized with a new blood test. This would enable us to measure 96 blood tests. From each of the spots there's a signal, and that's shown in the left hand panel. To show that the array is working well, we put a number of controls on the array, and then subsequently any chosen set of tests can be put together to make a saleable chip. Here we're demonstrating with CRP, which is an inflammatory marker, well-known inflammatory marker for many diseases. C3 is one of the components of the complement cascade. Transferrin is a iron transport protein. D-dimer is a blood clot molecule, and IgG is total immunoglobulin. So we can print along the surface of the array any of the assays we're interested in. There's an event marker there as the fluid front goes over, and then the fluid flows over the entire surface, measuring simultaneously the changes in all the assays at once. So as the blood sample flows over the surface, the assays begin to respond. You can see the big rise in the blue channel, that's the total IgG. It's in high concentration, it's an efficient assay. The changes are not all positive because of the complexity of the blood and the structure of the assay spot. And so this is a loading trace. So the general principle here we have called test and treat the patient. A recent survey amongst GPs has identified a set of assays that could be used for treating and triaging the health of patients in the community. The assays can be used for monitoring recovery in the hospital ward, where acute analysis would be interesting. And you can then intercept, for example, sepsis infections earlier by looking at markers of those sepsis and how they change rapidly. The obvious market where we can make some real change is the GP consultation, where we can provide the blood test results at the first consultation, saving all second consultations and subsequent follow-ups, and at that one meeting, setting the patient on the right path for recovery. The GP can begin to monitor patients in care homes, so the care home assistant can monitor routinely the physiology of the patient in the care home and report that back to the GP to keep the outpatient out. If the patient is transferred to hospital by ambulance, then the general diagnosis panel can be run during the transfer to hospital, so that on arrival they have an initial blood analysis, blood biomarker analysis, so that the right team of surgeons is meeting the patient coming in at the door. You can extend this into a number of remote environments, specifically, for example, military environments at sea, where you can monitor the health of all the sailors fairly easily, either routinely or during a battlefield scenario. Remote environments are very interesting. Long distances from hospitals means that the turnarounds of blood data may take several days. Indeed, it may not be possible at all. And if you are in a remote community, a simple test that can be performed by the patient can provide top quality, world-class blood diagnostic analysis that doesn't have to then be returned to the hospital. The idea of doing it in the developing world, monitoring Ebola epidemics, monitoring the staff that are managing the Ebola epidemic, monitoring the outbreak of all diseases, malaria or other viral impact, can now easily be done by a simple blood test. All of which allows you to make the patient their own baseline. So what's normal for you? As you get sick, you can then see a rise in your acute phase, and a rise in your acute phase is associated with you having an infection. If your acute phase is falling and continually falling, then you're on the recovery pathway to good health. So the APEX analysis lets us do just that. So the total antibody in the blue channel consists of a series of antibodies that are a result of your having had boosters for vaccinations, exposure to diseases you have seen before, and would include, for example, specific antibodies to Ebola and AIDS, for example, where after 7 days or so you will be carrying these antibodies and they can be detected specifically. Not only can we measure the total antibody concentration, but we could then set up specific assays for the Ebola antibodies and the AIDS antibodies and the malaria antibodies, and then measure the concentrations of those again in real time. We've just switched on the left-hand panel to a wash buffer, so the assays have now been loaded, and we will now look at the quantification process. Antibodies for immunotherapy, antibodies for vaccine response, all of those could be separated and differentiated to provide some real-time information about the immune response of a patient. So as the wash step occurs now, we're flowing over a quantified detection antibody that would enable us to measure precisely the concentration of the target biomarkers in the blood. Soon the image on the left-hand side will begin to show a rise in all of the channels simultaneously, depending on the concentration of each of the biomarkers, CRP, C3, transferrin, and IgG, as an example demonstration of the assays that we're preparing at the moment. So now you can begin to see at the far right-hand corner of the display the channels are producing quantitative results. These are telling us almost immediately what the concentrations of the molecules are. So you can see my blood has got a concentration of CRP of less than 1, which, because I'm healthy at the time of taking the blood, is normal for me. C3 at 0.95 grams per litre is below average, but again normal for me when healthy. Similarly for transferrin, D-dimer, IgG. This is all normal for me. This is my normal baseline. This is fully calibrated, CV validated compared with a clinical chemistry laboratory, and in the space of 8 minutes the GP now has information about whether you have an infection, whether the C3, C4 consumptions are there suggesting bacteremia, whether my CRP levels are high because I've got a general inflammatory event. So the power of this real-time diagnosis means that the patient doesn't have to return for a second consultation, doesn't have to wait for a diagnosis. We're proposing to launch a product with a number of chips, a general diagnosis array, a food allergen array, some more advanced blood profiling, liver and renal function, as well as a viral protein array. A simple diagnostic with real-time applications.